In this video, we're going to take a look at the Power Macintosh 8600. This was released in 1997 by Apple, and it's from the sort of era where Apple would probably quite like to forget. It's not the most stylish machine in the world, but forms the line of sort of the beige Power Macs that they used to have. This is the 8600/200, which means it's the 200 MHz model. This is the base model. Unfortunately, this isn't pristine condition. It's missing a panel here, but it's not too bad. And it's free, so I can't really complain. So let's take a look at it. So on the front, at the top we have a floppy drive, typical Apple sort of 2 meg floppy drive, and then it's got just a sort of pin to emergency eject it, because obviously these old Macs do motorized ejecting, so you purely need that if it jammed. CD-ROM drive, zip drive, although there isn't actually a zip drive in this machine. Unfortunately, it's been removed by the previous owner or something. So just put a bit of black card in to fill the slot. Otherwise, there'll be another missing bezel, so I may as well put the bezel on it to make it look at least a bit reasonable. Unfortunately, it's a SCSI zip drive, so I don't have a replacement. I've got a replacement IDE one, but it wouldn't fit in this machine. Then over here we have the PowerPC logo. This has a PowerPC processor, PowerPC 604E. Down here we can see the old-fashioned rainbow Apple logo, Power Macintosh 8600/200 sort of branding, and this grille which covers the speaker. Then over here we have the power button. So here we are on the back of the machine. So as we can see here, we have the power supply, which has IEC power in and out, as well as a bunch of PCI slots, because this is a PCI Power Macintosh. We can then also see down here we have a Kensington lock, so you could actually lock it down. So now here we can take a look at the rear I/O on the machine. So here we have a SCSI connector. This is a big D sub connector, AUI Ethernet, which I'll show in a second, regular twisted pair Ethernet, some old-fashioned Apple serial ports. This connection goes to the monitor, which you can use a sort of adapter for to convert to VGA. So in this case I have this old Lindy branded adapter here, which takes the DB15 there and outputs an HD15 there, and there's a bunch of dip switches to configure it. Then finally down here we have Apple Desktop Bus, audio, and then over here we have actually got analog video capture. So this machine has analog video capability. So we can see there's two different rows of connectors. This one's labelled in and this one's labelled out. So it can both input, capture and output analog video over these connectors. So that you have standard composite along with S-Video on the side. Interestingly as well, S-Video uses the exact same connector as Apple Desktop Bus, so you can kind of make a mistake there and plug things in the wrong way around. But yeah, so you can capture your video, edit it on the machine, and then you can output it to a VCR and record it onto tape. So I'll try and demonstrate that later. So at the time this machine was developed, Ethernet over twisted pair wasn't a sort of completely standard, not everyone used it. Lots of people still had old-fashioned coaxial based networks and various other sort of standards. So this is an AUI port, which allows you to connect different Ethernet interfaces to it, so you can connect different physical media. So for example, here I have this adapter, which is a standard designed for thin Ethernet. So this is Ethernet over coaxial. So you can see there on the back, there's the information about it. As you can see, it's a thin coax transceiver. And on the side there, we can see we have two BNC connectors. This is designed in a sort of bus network, where what you would do is each machine would connect into, which sort of the coaxial would go into a machine and then come back out. Traditionally, you would just have one connector on the machine and you'd use a sort of T-junction, whereas this does sort of straight pass through. And then you have this connector here, which is the actual AUI connector itself, which plugs in there. Now this has quite a cool locking mechanism. You'll notice if I pull on the cable, it won't come out. However, if I pull on the connector itself, it'll come off. This is because there's actually a locking mechanism on this. So the outer sheathing on the connector slides back and forward. So you'll notice when I slide it back, the pins at the top release slightly. When I push it forward again, the pins at the top lock in, like that. So that's quite a cool way to sort of lock the connector in place. Much nicer than having stupid screws or something. So now, let's crack this machine open and see what we have inside. So this case is quite an interesting design. So the first thing to look at is the locking mechanism. So there's just a button on the top here you press to release the side panel. But then if you wanted more security, there's a bit of metal that slides out the back, and you can put a padlock through this, which allows you to chain the machine down. But when this is slid out, it disables this button from being pressed to remove the side. So it can mean it's quite secure. So now to remove the side, press the button down and it slides off. I'm not a massive fan of designs like this because if this mechanism fails, it's quite often a case that the machine will get locked shut. There was an issue with that, way back with old Dell Pentium 4 Dimensions. Some of them had a mechanism like this, and it was quite common for the machines to get locked shut, which wasn't great. But yeah, so that's the side removed. Now inside the side panel, you can see it's quite interesting. So what we have is a fan mounted in here. So this is mounted, it extracts air and blows it out the side. And then over here we can see the connectors. So there's these two sort of spring-loaded terminals here on the side panel, which mates up with these connectors located down here that we'll see in more detail in a minute. And that's how it connects the fan up. And this is the fan that cools the processor. So now here's the interesting design of this case. So now, if you wanted to access the motherboard of this machine, you'll see that it's located under all this drive-based stuff. So how do you get this out? Well, it's actually quite an interesting design. And it also explains why the machine has this weird sort of corner cut out of it here. So what you do is there's a latch here and at the back, so you undo these latches, which are interestingly made of sort of this translucenty green plastic, which Apple sort of moved to obviously with the iMac and stuff, but they were using it back here but just on internal stuff, which is a bit strange. But yep, you've undone those latches, and then there's a handle here, and that all hinges over, which is pretty cool. So that's a bit of a strange design, but I suppose it works. And you've now got really easy access to the entire motherboard. So now here we can see the inside of the machine. So first of all, over here we have this little assembly here. This contains a speaker which plays out the front, along with these terminals, which are what goes up and connects onto that fan on the side panel I showed earlier. This then connects down to the motherboard with two different cables. The blue cable just goes to the speaker, and the red and black cable here goes and powers the fan over these terminals here. It just goes straight up through and onto those terminals. Now over here we can see we have 3 PCI slots, and there's a sort of big blank space down the bottom. This big blank space here is for the motherboard in the Power Macintosh 9600. The 9600 was very similar, it used the same case, but it had more PCI slots. So that's why there's just this big blank bit filled in here. Which is a bit silly because the machine is now significantly bigger than it needs to be. Now over here we can see we have the processor. This is the PowerPC 604E. So to remove that, it's just in a slot, so it carefully slides up and pops out the machine. You can see there's the back of it. It's fairly plain. I'm not going to risk taking the heatsink off just because it'd be a bit of a nightmare to put back together. I mean, if you actually look under there, there's actually, I think it's a voltage regulator of some sort, actually connected to the heatsink. And that's actually screwed in place there, so I'm not going to take that heatsink off. But yeah, there's the bottom of it, you can see. Also interesting is this sort of 2-layer connector, because obviously you've got the upper pin, like small pins for data, and you've got these big bars down the bottom which will provide power to the chip. And you've got that on both sides. So here's the other side where you can see you have the heatsink, which is fastened down there. You can see some model up there, copyright 1997. And you might just be able to see under there, you might be able to just make out the chip. It's a tiny little ball grid array thing here, just under there. It's surprisingly small, but yeah, that is the processor. And it's just in this card. Now you'll notice it isn't locked in place by anything on the motherboard. That's because, so if you I'll show you, so if you put it back in the slot, so that's back installed there. What happens when you fold the lid of the machine over again, these little plastic clips here on this bit latch onto the processor. So you put that down and that holds the processor in place. So that's how the processor is locked in place. Now we can take a look at the rest of the motherboard. So it's interesting to see this motherboard because it's got so many slots for memory. So what you have here is you have these 8 slots here which are for just standard system RAM. These are EDO sticks. So as you can see, there's 2 sticks here, 2 sticks here. Each of those is 16 megs, which gives this machine a total of 64 megs of RAM. But then what you see here that is more interesting is this slot. This is actually the CPU cache memory on a card. So this is 256 kilobytes of cache, and it's stored in here. You can actually see on the motherboard next to it, it has the word cache printed very small. Over here, we can then see we have the VRAM. So there's 4 slots for VRAM. There's currently 2 populated. Each of these is 1 meg. So this gives this machine a total of 2 megs of RAM, or of VRAM, sorry. So that's obviously for the onboard video. You obviously have some PCI slots here, so if you wanted to have an add-on graphics card or video capture card or whatever, you can just install it here. Another interesting thing down here is this slot here labelled DAV. This is for the onboard video capture. So what happens is if you don't want to use the onboard video capture chips in this machine and want to use an add-on card that's better, you can connect your add-on card to this, and that effectively allows your card to connect through to the physical connectors located on the back of the machine, so you don't have to have like connectors on your card itself. It's pretty interesting. I don't know how much that was ever used for cards, it just seemed to be put in there just in case someone wanted it. Down here we can see we have the CMOS battery, or the NV RAM, or the PRAM, or whatever Apple called their sort of volatile system memory, the battery that backs that. The top of the connector just sort of lifts off, and there we can see it. It's a 3.6 volt lithium half AA. Unfortunately, this machine is dead and I'll need to replace it. I just need to go and try and order a replacement from somewhere. Unfortunately, it's not really a type you can just get in a shop. The other interesting thing is down here is the power switch. So on most machines, the power switch is like a cable that goes off to a thing on the front of the case. Whereas here, it's actually this button soldered to the motherboard. And when you press the front of the case, that bit of plastic moves in and presses the button. You then have this cable which goes to an LED located on this plastic. At the rear of the machine here, we can see we have the SCSI connection from the drives. There's currently one. There is provision for a second slot, so you could put another SCSI cable in there if you wanted. Although I don't know where you'd put the drives, because there's already enough cable connectors on this cable to suit all the drive bays in the machine. Here we have this large power connector from the power supply, along with the second auxiliary one. Here we have the connection for the floppy drive, which is interesting because it carries the power as well. It's not like a standard PC floppy drive where you have a separate data and power cable. It's got this quite small connector, and that carries data and power to the drive. And then finally, buried under this, you see a connection here. This is the old-fashioned CD audio cable. So this comes from the optical drive and connects directly to the motherboard for audio from CDs. Here we can see the rear of the board that connects the AV connectors. So there's a few components on the back, but nothing really that fancy. And that then connects off on this ribbon cable that goes down to the motherboard. So now here we are in the drive bay of the machine. So over here is the power supply, which is made by Delta Electronics. It's a 390 watt unit. And up here we can see we have the hard drive. So this is held in with these two screws here, and then we can remove those and we can see the hard drive. So unscrews. That. So now with the hard drive unscrewed, we can disconnect the connection from the back. So the SCSI ribbon cable can come off, along with the Molex power, and then drive will now slide out the machine. Pretty clunky mechanism, it's not the nicest, but it does work. So you can see on the bottom, drive's held in this bracket with 4 screws. And if you look at the top there, we can see this is a Seagate Hawk. So that's the bird or animal they've named it after. There's a model of it there you can see there. And as you can see here, this is an official Apple branded drive. It's the original one for this machine. This is a 2 gig drive. And it's pretty slow, but it does the job. In order to remove the other drive from the machine, there's these little tabs on the faceplates, so you can simply press that in and then the faceplate just comes off, like that. The same for the optical drive. Obviously not bothering with the zip drive because it's not actually in there, but on the front of each drive you can now see there's a metal plate with 2 screws. So all you need to then do is take these 2 screws out, and that will remove the drive. So each drive's covered with this sort of metal shield. I don't really know the point of this because it's just, you know, if you didn't have that, the plastic would still cover it. I'm wondering if it's some sort of RF shielding, given that it's got sort of contacts here, obviously to like make it sort of snug with the case. So I'm wondering if that's some sort of RF shielding type thing. Okay, so with the drive now unscrewed and the cable removed from the back, we can now remove the drive from the machine by simply sliding it out. So here's the floppy drive. On the bottom, we can see we have the screws holding it in. There's various different holes, so there's holes for floppy drives and for hard drives, and then these holes off the side are if you're using a 5¼ inch optical drive. So the same carrier is used for all types of drive. It also means you can install extra hard drives in those bays if you wanted to. So that's quite nice here. This has an Apple logo engraved on it, so it is sort of branded by Apple, which is nice. There's the back of the drive where we can see we have that single connector that takes power and data. And on the top we can see this is made by Mitsubishi. There's the model of it there. Now in the front of the drive, we can see there's no plastic bezel because obviously that's part of the case. But then down here we can see there's a little emergency eject button. So if you put a floppy disk in, you'll see the button pops out, but not nearly as far as it would on a normal floppy drive, because it's not actually trying to protrude from the case. It's just so if it jams, you can poke something through. So you press that, it releases the disk. It's a slightly different mechanism to a normal floppy drive because of the motorized eject, but it's still very similar. What I also quite like that they've done here is on this button they've cut a little pit out of it, so when you're pushing like a paper clip or something in that hole in the front, it'll naturally sort of sit into that rather than sort of missing and going inside the drive and damaging something. So that's pretty neat. So now we can do the same to remove the optical drive. So again, as before, screw on either side. Disconnect the cable from the back. And the drive will just slide out. So there we go, there's the optical drive. So as you can see, it's a 12-speed CD-ROM. Again, all proper official Apple parts. Obviously SCSI, all the drives in this machine are SCSI. And it was manufactured in March 1997. Looking at various date codes around this machine, I guess it was probably made around the summer of 1997. Here in the back we can see there's the connectors. So there's that audio connection to the motherboard. Some jumpers for setting the SCSI ID and various other SCSI settings. SCSI connector, and the Molex to power it. And the front is just a standard optical drive. It's quite funny here how they've obviously used the same mould that they've used for other drives, because it's got the headphone logo and sort of volume thing printed on it for where you'd have a headphone port and a volume knob, but it isn't actually fitted on this drive. But this is all covered by the bezel so you don't see it. So now let's reassemble this machine and get it fired up and see it running. Okay, so now let's fire this machine up and see it running. So I've got it connected up to an old monitor over that VGA adapter, and I've also hooked up this old Apple design keyboard. You can see the back there, it's the Apple design it's called. It's an absolutely horrible keyboard to type on, but it works. As you can see, it's standard Apple desktop bus, so the keyboard connects to the machine and the mouse goes into the keyboard. Then for the mouse, it's just a standard old-fashioned Apple single button mouse. So now let's fire it up. So there you go, that's now booting into macOS 8.1. So this machine was sort of on the border between macOS 8 coming out and System 7. So I thought I'll put 8.1 on because it's still roughly period for this machine. I mean, these sort of early models of this would have been System 7, later models would have been 8. And System 8 macOS 8 is just a little bit better. It just got a little bit more features. So you can see it's still old enough though, being 8.1, that it just says macOS on the boot screen. It doesn't say actually have the version number on it. So that's it, booting up now. And you hear the noise of the old SCSI hard drives in these machines. They're really loud, it's ridiculous. So now here we are, the machine is finally booted to the desktop. So here we can see classic macOS 8.1. This sort of classic Mac environment is very sort of nostalgic to me, because when I was in primary school, which is like elementary in the US, we used to use Macs like this. We had a mix of iMac G3s, but mostly iMac G3s. Laterally we got iBooks, but there were still a few of these old Power Macs and similar sort of machines from the Performa range dotted around. I remember using these. In particular the old SCSI hard drive, the noise they make sort of reminds me of sitting there waiting for hours for these machines to do things. So you go to the Apple menu and go to About This Computer. And as you can see here, it's showing up macOS 8.1, 64 megs of RAM, and yeah, there we go. So I'll take you a bit closer and we'll take a look at the OS a little bit. Cool, so here we are. So, let's see what we have installed on here. So first of all I've installed ClarisWorks, mainly because it's one of the things I remember using when I was in primary school. It's quite nostalgic. Well, this and AppleWorks 5. These different machines had different, some had AppleWorks, some had ClarisWorks. But here it is installed. You can go into the old word processing program and do word processing, and then you've got the sort of paint document and you can do things in this. And I actually found some old photos that I'd printed out, or not photos, but like drawings I'd printed out that I'd made in school on ClarisWorks, so it's quite fun. I remember using this. I used to be pretty good at it. Like I knew how to work it properly. What I've also installed, I've installed IE3 and Netscape 4, so we can actually use this to get online. So I've connected it up to the network with a standard Ethernet cable and just configured it just to do DHCP and get an IP address. And you'll see it will actually work. Now, it'll fail to load the Apple homepage because it tries to use SSL, and obviously these browsers are far too old for SSL. but we can try and load some sites, so I think BBC probably works. Maybe? It might be a little bit slow. Well, obviously it'll be slow, it's a very old machine. But yeah, there's IE3. We never really used IE3 on them. Oh, there we go, it's actually loading. Yep. Ooh, yep, JavaScript errors. Might get something out of it though. Yeah, we didn't particularly use IE3 on them. We used to use IE for Mac, so it was the old one that was sort of a bit newer, you could change the colours of it and stuff. But I distinctly remember using Netscape 4. I don't know why I used Netscape, because we were never told to, but I just always seem to use Netscape on these machines just because it was cool. I don't know. But yeah, there's IE being incredibly slow, and it's crashed. But yeah, we'll take a look at Netscape. Seems it's a bit better, so if we open that up, this brings back a lot of memories. And then we have Netscape 4. Obviously, trying to load modern web pages, this won't work very well. I'll try and load BBC again just for a laugh. The BBC site's reasonable for loading in old browsers. So obviously it's trying to run JavaScript, but it has no idea what it's doing because it's such an out-of-date JavaScript engine. But hopefully, if I can... Oh, too many JavaScript errors. That's hopefully just stopped it running scripts. Oh god, so many errors. But look, there you go, you can see in the background it has actually successfully loaded the BBC homepage. So we can, yep, scroll down and that loaded. And for a bit of a laugh, let's look at some more websites that are actually from the time period. So for example, I've got a couple of bookmarks, so we can look at the old Warner Brothers Space Jam movie website. This is quite amusing because it's a website from the mid to late 90s, but it's still live on the internet. Now it's giving JavaScript errors because they've put Adobe Omniture Analytics tracking on the site, which is obviously a way newer system they've put on, but that's now causing the error. But apart from that, yes, it actually successfully works, so you can actually use this really proper 90s website, and it's still online today. The URL's up here. There we go, yep, there you go, copyright 1996. So this website was released a year before this machine was, so it's fairly accurate for the time. And also, since we're using Netscape, we can look at the good old Internet Explorer's evil website, which also works in this browser. And it's quite cool looking at the old stuff because it's like it renders it perfectly, and it's like being back in the 90s with these old web pages. So now let's take a look at the analog video capabilities of this machine. So I've hooked up this old mini DV camcorder. It's an old Sony Handycam. It's from about 2005, but yeah, it's like old Handycam, and it's connected over composite into the machine. So the program we're going to use to capture the video, at least at first anyway, is the Apple Video Player, which comes pre-installed. And as you can see, that's open there. And now if we turn the camcorder on, we'll start seeing video on the computer. Yep, we can move the camera around, and that is the video. So what you can do is, for example, you can take still photos from it. So we can point it there. Be very careful because it's giving me audio feedback. I'll turn the sound down to stop it doing that. And what we can do is on the side here, we can go to the camera. We can save a capture, and that'll save a picture. We can do another one, so we can take a photo of, I don't know, the keyboard this time. Save. And again, save that image to disk. And now those pictures are saved, we can open them up. And that is a frame grab from the video we just took. Now of course, taking photos is one thing, but the more interesting one is actually capturing live video. We can do that as well. So there's a note here saying, reducing the size of the video window will improve the quality of the recorded movie. That's because if the window here is too big, it just sort of overloads the CPU, I think. So we can go to the Windows menu and set it to smallest size. I've also turned off virtual memory because the program moans if you've got virtual memory enabled. I think that also mucks up the video quality. So what we can do is we can hit record, and that is now live capturing video from the camera. So film around a little bit. Obviously it's quite a small preview, but we'll be able to see the full quality once it's done. There's quite a bit of delay. Yep, so I filmed some video there. So now stop recording, and it'll ask me to save to disk. So I'm going to hit save, and that's our movie file saved. See how big it is. So that file, which is a few seconds long, is 19.6 megs. It's not massive, but it's fairly big by the sort of standards of the standards of the day. So we can now play back our video. So here it is on the desktop, we can open that up. Interestingly, it opens in simple text for some reason, which doesn't really make any sense to me whatsoever. But yeah, we can pull it down here and we can take a look. Obviously it's very low resolution, but let's play it back. And that is now live capturing video from the camera. So, filming a little bit, obviously it's quite a small preview, but we'll be able to see the full quality once it's done. There's quite a bit of delay. Yep, so it films some video there. So I'm going to stop recording. So you'll see there it sort of pauses every so often. You particularly notice it in the sound. That's because it's writing to disk. Unfortunately, the disk in these machines is really slow, so actually just the sheer having to write out to disk causes the video to stutter. So video capture, especially in that program, isn't particularly good. So now let's try something a little bit more interesting than just capturing the video. Let's try editing it. So I've installed Adobe Premiere 4. This is from 1994, so it does predate the PowerPC Max, so it's probably not optimised for this machine. It's not going to perform great, but it at least does work. We can import the file, we can edit it, and we can export it again. And we're not doing a big project, we don't really need to care about the performance too much. So I'll just create an empty project with a preset that works. And let's now capture some video from the camcorder again. So we go to File, Capture, Movie Capture. And it's asking me to turn off Apple Talk. That's because if Apple Talk's enabled, it slows it down or something. Imagine that nowadays, like if you had to disable your computer's networking when importing videos. So I've also just turned the audio off there just because we don't want it to, get feedback, because that's horrible. So turn the camcorder on again, and as you can see we start getting a feed from the camera. And now let's hit record. So we're now recording some video from the camera. I'll just film a wee bit boring stuff around the table because I'm not getting anything exciting to film. We take a look at the machine. PowerPC there. A wee bit of fun with that. Yep, there's transitions. And there we go, so we now captured some video. So we can now click the cursor to stop recording. If we switch the camera off, turn the sound back on, we can now see our clip coming back. So we're now recording some video from the camera. The video playback in Premiere is so much smoother than it is when you use the Apple Video Player. So I think this is just generally a better way of capturing video. So what we can now do is now import this clip into our editor. So where you can just pull the clip over and drop it in there. Ask me to save it, I'm just going to save it there, that'll do. And that's our clip now importing. So what I'll do to edit this is I'll just cut a chunk out the middle and I'll put a transition in place. So all we need to do is there's a razor tool here. I can work the razor tool. I mean, I'm not a video editing expert, as you can probably tell by my videos, so I can cut videos together basically. So here we go, we can cut this one. Just cut that little section there out. Now we just delete the video, delete the audio, and what we now need to do is we're going to use the band slide transition. There's various transitions, see there's a list of them. There's quite a few quite exciting ones actually, it's quite, yeah, there's various transitions on here. But yeah, we're going to put a transition in and we're going to try and see how it works. So let's use band slide, it's basic enough. Put that in there. And then we'll put this clip on the track below, so they're now overlapped at this point. This is now where we're going to have the transition. So you can see here's the preview, it's showing. I need to show the controller so we can actually see it. There we go, so we can try and tell it to play this back. So what you're seeing here, it's been across where the transition is meant to be. You obviously need to render it to actually get the full transition. So let's render it. So the first thing you need to do is you need to this little yellow bar here is the amount this will render. So if you double click that, that'll expand it to fill the whole clip. Otherwise you'll only render the first few seconds. Then we go File, Export, and export to a flattened movie. The flattened movie is effectively an MOV file. So save that to desktop, and it's now going to build a preview. It'll take a wee while it renders. What you'll see is it renders the first bit it renders the video on its own really quickly, and it spends its entire time just sitting on the transition. So it must just be able to export those files just directly with no pre-processing, and then it sits and has to actually render that transition. So we'll wait while this happens. And now we can save the file to the desktop. And that's now saved our file. So if we get rid of that, here's our file we've rendered, so let's play it back.
So we're now recording some video from the camera. I'll just...
Look at that state-of-the-art transition there. So yeah, that's our finished video. So we've successfully edited a video on the Power Mac 8600. And now, through the magic of Apple Talk, an iBoot G3 and various video conversion programs, I've actually converted the video and imported it into my video editor. So what we're now about to see is the raw video file played directly. So here we go. So we're now recording some video from the camera. I'll just... the machine. PowerPC there. So let's turn the machine off. So as you always do with these machines, you just go to the special menu and go to shut down. And they turn off really quickly. So there you have it. That was a look at my Power Macintosh 8600/200. It's not the most exciting machine in the world, but it's a pretty, pretty cool. I mean, the video capture's quite nice. And yeah, it's a sort of shows an era of Apple that they'd probably rather forget, given the design of the machines. But yeah, thanks for watching. Don't forget to comment, rate and subscribe. You can also visit my website at camengray.me and follow me on Twitter at camengray1515, and stand by for more videos of this machine along with other vintage computers coming in the future. Thanks for watching.